In this exercise, we'll solve a system of 3 equations and 3 variables. And this is the system of equations: 6x plus 2y minus 4z equals 15, negative 3x minus 4y plus 2z equals negative 6, and 4x minus 6y plus 3z equals 8. Now I'm just going to start by numbering these equations 1, 2, and 3, just so they'll be a little bit easier to refer to as we proceed. If you see a system of equations in 3 variables on a test, before you just plunge in and start doing things, it's a good idea just to step back and take a look at it and see what the most efficient way to proceed would be. We want to use 2 pairs of these 3 equations to eliminate the same variable from each pair. So I just want to look at the coefficients of the variables and see which would be the best to choose. And when I look at the y terms, I see that the y term in equation 2 and the y term in equation 3 are both multiples of the y term in equation 1. And that isn't the case. They're integer multiples. And that isn't the case with the x's or with the z's. So I'm going to choose the y term to eliminate first. And I'm going to use equations 1 and 2 to begin with and eliminate the y from that pair of equations. And I see that if I would multiply equation 1 by 2, I would have a 4y, which would add up to, with a negative 4y, to 0. So let's begin by multiplying equation 1 by 2. And when we do that, we have 12x plus 4y minus 8z is equal to 30. And then I'm going to add this to equation 2. And when I do the addition, I get 9x. The y's add up to 0. So I have 9x minus 6z is equal to 24. And let's call this new equation equation 4. Now I'm going to look at equation 1 and equation 3 together and eliminate the y term from that pair of equations. And I see that if I would multiply equation 1 by 3, the y terms would add up to 0. So let's do that. When I do that multiplication, I get 18x plus 6y minus 12z equals 45. This is equation 1 multiplied by 3. And I'm just going to write equation 3 under it. 4x minus 6y plus 3z is equal to 8. And now I'm going to add. And I get 22x. Again, the y's add up to 0, which is exactly what we wanted to have happen. So I have 22x minus 9z is equal to 53. And I'm going to call this equation 5. And now I've got a system of 2 equations and 2 variables, the equations that I called 4 and 5. I have 9x minus 6z equals 24. And I have this is equation 4. And I have this equation that we just found, 22x minus 9z is equal to 53. And this is the one we called 5. Now I'm going to solve this system of equations for one of the variables. And let's eliminate the z terms here. This will be the easiest to eliminate. If I would multiply the first equation by 3, equation 4 by 3, and if I would multiply equation 5 by negative 2, I would have a negative 18z plus an 18z, and the z's would be eliminated. So doing those multiplications, multiplying equation 4 by 3, I have 27x minus 18z is equal to 72. And now I'm going to multiply equation 5 by negative 2, and I'll have negative 44x plus 18z is equal to negative 106. And when we add, we get negative 17x is equal to negative 34. And now if I divide both sides by negative 17, I've solved for x. I get x equals 2. Now I also want to solve for y and for z. I'm going to take this value of 2 for x back to either equation 4 or equation 5 to solve for z. And let's just use equation 4. It's just an arbitrary choice at this point. Substituting 2 for x in equation 4, I have 9 times 2 minus 6z is equal to 24, or 18 minus 6z equals 24. I'm subtracting 18 on both sides, and we have negative 6 times z is equal to 6, and dividing both sides by negative 6, we have z is equal to -1. And now I know a value for x and a value for z, and I need to find the other variable y. And I'm going to go back to one of the three original equations to do this, and we might as well just use equation 1. Remember, equation 1 was 6x plus 2y minus 4z equals 15. And so far we have found that x is equal to 2 and z is equal to -1. So I'm going to substitute 2 for x and -1 for z in this equation and solve for y. In doing the substitutions, I have 6 times 2 plus 2y minus 4 times -1 is equal to 15. 6 times 2 is 12. Oops. And this multiplication gives me 4. 12 plus 4 is 16, so I have 16 plus 2y equals 15. When I subtract 16 on both sides of the equation, I get 2y is equal to -1. And finally, I'm going to divide both sides by 2, and I get y is equal to -1/2. So we have the ordered pair 2, -1/2, -1, and if we would check these three values in each of the three original equations, we would find that they do satisfy each of the three equations. So this ordered triple is the solution of the system of equations.